Okay, this is problem 12-122. It was not assigned, but it's one that could use all your equations. So if you get, it says determine the reaction supports A and B. Again, first thing to always do in these is draw yourself a free body diagram. Anytime you have a cantilever beam, you're always going to have a moment at this end. Here, you'll have a vertical load, and you could possibly have a horizontal load. However, here you have no horizontal load being applied, so immediately you can take that one away because that one's going to be 0 anyway. You have that one, and then we have a reaction coming back up here. And then we also have a moment of being applied here. Okay, so first thing to do is to take a moment, and we're going to take a moment around A. If I take a moment around A, I will get MO. We make that negative because it's going down. And we better make this FB here. Plus we got FB times L. Now the problem is you can't just set that equals 0. You have to consider this moment at A. That's only for cantilever beams. And it's going back that way, so we can put plus MA is equal to 0. So if I sum my forces in the y direction, then the only thing I would get would be FB minus FA equal to 0. FA would equal to FB. Since this is going up, this must be going down, so we have this one oriented the wrong way, so we can turn around and go back this way here. Oh, sorry. I need to put that like that. Okay, now what you want to do is you want to say, well, what's really taking place here? I need to find out what this beam's going to do. Well, we know from looking here what's going to take place is this moment here is going to want to bend this beam like this. This one here is going to want to bend them back up like that, the force B here. Alright, so we do that. We have a moment at one end, so we come down to your table and you say, well, I'm going to have to use this one 3. So I'm going to use these equations here. What else? I have a load at the end, so I'm going to use B. So I'm going to use these values here. 1 and 3. 1 and 3 are going to be the ones I'm going to use. Now I'm going to go ahead and delete this. I have these saved down below. We'll come back down and bring those back up here. Go ahead and erase this. Erase this. Bring this one. And let me grab the other one too. So again, these are the two things that we're going to use. And all we really need to do is set the deflections equal to each other. We can basically say the deflections have to equal 0. Because I can say the deflection as a result of this plus the deflection of that one added together must be 0. Because this beam, obviously ground is not going to move. This beam has got to be flat. So go ahead and do the first one. We say P here. Again, maximum deflection is going to be at the end. We can use this equation or this equation. They're going to give you the same thing because this just means max. It's going to be easier to do the max since you're at the end here. So we start putting the numbers in. We have P times L. Now in this case, we'll take P out because P is just going to be the force of B. Okay, and then we're going to do L cubed here over 3 EI. I will set that equal to deflection of a moment that's coming down here. Again, you can change these signs depending on whether what it's doing. The moment is going up, you can make one be negative, or if it's going up, make this one be positive. Here I got the moment. I'm sorry, I'm being stupid. Second. Moment times L okay, and then we come back up here. We're going to use this one here, or you could use this one here. It's going to be the same thing. You just let x be L here, and you get exactly the same thing. We're going to set those equal to each other because the deflections are going to be the same. And again, if you get concerned about the minus and plus, it's because if you add the two together, you get 0, and you move to the other side, it'll give you a positive. So that's going to give me my moment, and my moment was going to be, what was that going to be? MO, I believe, times L squared over 2EI. So now simplify as you can, and what's going to happen, I is going to cancel out here. So now I had FB, so let's just solve for the force of B. So FB is going to equal to MO. We're going to divide it both sides by L cubed. That gives me an L down here because this will cancel out, over 3. Let's see here. Bring the 3 up here and bring the 2 stays down here. There we go. So FB is going to be equal to 320 ml. Now all I have to do to find the reaction at A is I go back to this equation right here. And let's just grab that right now. Oh, I can try it one more time. I don't know what I'm getting. I'll rewrite it. Sorry. Summation of forces in the y direction was going to equal to FB minus FA. So is equal to FA. So we know that AY also is going to equal to 3 MO over 2L. Now we go back to the summation equations of the moments here, and let's try one more time to grab this. I don't know why I didn't get it all right the first time. There we go. Go ahead and erase this one because we just did this above. Okay, now we have to put everything in. So we got minus MO plus FB. We said FB was right here, was 3 MO over 2L times my L here. My L's cancel out here. Plus MA is equal to 0. So here we got, so let's just make this 3 over 3 to get common denominator. And that was a minus. So then when we subtract, that gives me minus MO over 2 plus MA is equal to 0. Solve for MA, and MA is equal to MO over 2. And we solved everything. We got our MOs, we got our AYs, and we got our BY too. Same thing. Alright, so that's how how these work. Again, at your maximum deflection, like it depends. If the cantilever beam is usually going to be at the end, you can use these equations here, or you can use this one. This equation is going to be for when I need the deflection anywhere along here. I would also recommend that you spend a little bit of time looking at the slopes equations. Basically, the slope means I can find this angle in here any place I want by using this value here. Good chance you're going to be given a problem that has a combination of different forces, and you're going to have to either add or subtract the slope equations. Alright, I hope that helped.